In the first problem, we have that a diode has a voltage of 0.6 volts for a value of VPN when the current IPN is equal to 1 milliamp. And then we have another reading that VPN is equal to 0.7 volts when the current is equal to 9.83 times 10 to the minus 3 amps, 9.83 milliamps. We'd like to find the value of the exponent eta for this problem, and the way to do it is to use the equation that says IPN is equal to I sub s times E, and the exponent would be VPN divided by eta times V sub t. There's a minus 1 over here. Well, to make it a little bit easier, let's ignore the minus 1 because this is going to be very small compared to this term. So we've just dropped this part out to make this an approximation. Now we have two data points to work with. We have this one over here. V sub t at this temperature, which is equal to K times T over Q, is equal numerically to 25.26 millivolts. So we can now take the ratio of the two currents. Let's take this one in the numerator and this one in the denominator. So I have 9.83 times 10 to the minus 3 is to 1 times 10 to the minus 3. Now the 9.83 came about from doing this. I sub s E to the VPN divided by eta times V sub t. And this is divided by I sub s times E to the VPN divided by eta times V sub t. Well, V sub Pn for the 9.83 was 0.7 volts. So I'll put a 0.7 up here. And VPN here for the second part, for the 1 milliamp, was 0.6. Now eta is the same eta. I sub s cancels I sub s. The V sub t we're told, or already figured it out, is 25.26 times 10 to the minus 3. So what I have at this point is that this cancels this. I have that 9.83 is equal to E to the, now if I subtract 0.7, take away 0.6, I have 0.1 over eta V sub t. Just taking a ratio. Take the log of both sides. I have the log of 9.83 is equal to 0.1 over eta times V sub t. So I know V sub t is 25.26 times 10 to the minus 3. I know that, so now I need to solve for eta, and eta is equal to 1.732, which is the answer to the problem. In warm-up problem number 2, we are told that a diode has a voltage across it of 0.6 volts when it is driven by a current source of 1 milliamp. Now the temperature drops 50 degrees, so the temperature will go down 50 degrees. We'd like to find what the new voltage across the diode would be. Well, from equation 811, we know that the change in voltage with respect to temperature is approximately minus 2.2 millivolts per degree C. So if you're going to drop 50 degrees, then delta V will be equal to minus 2.2 millivolts per degree C multiplied by minus 50 degrees, which gives us 110 millivolts. Well, the original voltage was 0.6 of a volt, so we take the 0.6 and we add to this 110 millivolts, and so the new voltage would be 0.71 volts. 0.71 volts is the answer.